Hello, everyone, and welcome to CircuitStream's Introduction to Unity Mars webinar. Before I do proceed, for the folks in the chat here on the right, can you please let me know, a thumbs up, a yes, a yay, or a nay? Can you all hear me? Can you all see me? Yes, Amy, thank you for letting me know. Jeff, Noah, everyone sounds great. Awesome. Okay, let's continue. A couple housekeeping items before we move on. It seems like a good deal of you have already discovered the chat tab over there on the right. At the top of the chat tab, you will see a questions tab and a polls audience. I would like to ask everybody in attendance, please, if you do have questions, please add them to the chat, or pardon me, the questions tab, not the chat tab, up there at the top right of your screen. It helps us stay on track, stay organized. I do have a few colleagues behind the scenes here supporting me this afternoon. And then throughout the presentation, I am going to be dropping in a few polls. So please navigate over to the polls tab as well when I do drop those in. I will give you some forewarning as well. I always love to lead webinars with these questions here. For those of you who are located internationally, we will be recording this webinar. It will be sent to everybody in attendance here today. So if you do have to log off at any point, please don't sweat. Don't worry about it. We will be getting you the recording as well as the project assets for today. But I am curious, where is everybody joining us from today? I myself am in Toronto, Canada, but I always love to see where people are joining. So I'm going to check out the tab here. I see England, Kabir, nice to see you. Toronto as well, Jeff, there you go. You'll love my intro slide in a minute here. I see India, Calgary, Spokane, Washington, Vancouver. Nice to see everybody. Wow, Spain too. Hello, buenas tardes. Nice to see you. Ireland via Sweden. Wow, Brian, I'd love to hear your story. That's fantastic. Well, thank you so much, everybody, for joining us. I'm super excited for today's conversation and today's workshop. It's a fun one for us. I just want to let everybody know I am going to take about 10 or 15 minutes here just to introduce CircuitStream, the company, just talk a little bit about who we are, where we come from, and what we're all about. At that point, I am going to pass things off to my colleague, Jerry, who's waiting behind the scenes. He does have a technical presentation and project walkthrough that we're going to be running through. Following that presentation, I am going to take about 5 minutes to wrap things up, just to summarize everything that we've spoken about and everything like that. And then by the end of that wrap-up presentation, Jerry is going to be joining us once again for an in-depth Q&A session. So without further ado, let's get started. So everyone, my name is Kyle. I am on the education team here at CircuitStream. I'd just like to tell you a little bit about myself. I do bring about 3 years of sports and tech experience. Prior to joining CircuitStream, I did have the pleasure of working with a major sports company here in Toronto called MLSE. A little fun fact about myself, yes, I am an NBA champion. I've got my ring right over there on the wall. It was one of the most amazing experiences of my life. No, I was not a player. I'm about 6 feet too short to be a player, and I have no sports skills whatsoever. However, I did work on the sales team there in the ticketing department, so it was quite fun to be involved with that. I've always been passionate about tech, though, so I joined the CircuitStream team to help educate the masses on how to build this exciting technology. Today, I am going to be joined by my colleague, Jerry, as I mentioned. Jerry is our head of education, and he's our lead instructor here at CircuitStream. He brings a wealth of knowledge and tons of experience across the AI, XR, and game development spaces. Jerry is a man of certifications, if you can't already tell. He's a Unity certified instructor, Unity certified programmer, and he's also a certified scuba diver as well. So if there's any scuba divers in the chat, I'm sure Jerry would love to connect with you to chat about that as he does that in his spare time. Now, moving on, CircuitStream. So our team, we're a Canadian company headquartered in Calgary, Alberta. We were founded in 2015 when we noticed a gap in personalized training and education. To date, we've educated over 30,000 students to help them learn the ropes and manage their own VR and AR applications. As you can see from our map here, I love how international we are. We're a team of about 20 experts who have all come together from different backgrounds to educate folks, like who's in attendance today. CircuitStream is a Unity certified training partner. What exactly does that mean? Well, we are certified by Unity given our commitment based on our expertise, our focus on quality education, and our commitment to providing the highest level of training in this industry available. More recently, we've also become an official Unity channel partner, where we deliver training and application development services in the architecture, engineering, and construction spaces, as well as the automotive and transportation industries. Those who complete our 10 and 8-week courses, which I'll speak about in a few minutes here, do gain our certificate of completion as well. Now, at CircuitStream, we really focus on 3 main things. The first thing, and what we're focusing on today, is the education and training pillar of our business. Here are some of the logos from the organizations that we've had the pleasure of having in our programs. As you can see, we've worked with places like, or organizations rather, like the US Navy, Walmart, Boeing, Facebook, Nike, YouTube, Hershey's. Yeah, you better believe we made the VR chocolate company. So I always love telling that story. Now, how do we deliver this? Well, the XR Development with Unity course is the program that really started it all. It's our flagship product or service within the education and training pillar of our business. I'm going to speak a little bit more about this program later on this afternoon, but for now, all you need to know is that it includes 40 hours of live education taught over a 10-week span. It covers all of the fundamental best practices of developing VR and AR experiences, and our next cohort is set to commence on the 1st of December. Registration is underway, so if this is something you're interested in learning more about, stay connected with us after, and we'd be happy to chat about your learning goals. Now, on the right of the screen here, you can also see our recently launched XR Project Accelerator program. This is a program for those folks in the room who don't really need to learn the fundamentals of programming with the C# language or the Unity interface and editor itself. We've taken everything that we've learned about online education, and we've created a project-driven program designed to help accelerate what you're already working on, while also focusing on learning more advanced best practices in weekly labs. Now, as you can see here, the date is obviously yesterday. I'm well aware that November 9th was yesterday, so please don't worry about it in the chat. However, this slide discusses the first course of a whole new series of short courses that we're going to be offering moving forward. Basically, if the full 10 or 8-week course isn't the program for you, we've also broken down specific topics in XR development, design, and art, as well as platform-specific development if you want to focus on a particular headset. So we're going to be launching no fewer than 7 courses later on this week. These courses vary from 1 to 6 weeks in length. They're all part-time, they're all live, they're all online. Some focus on the devices themselves, like the Oculus Quest 2 or the Microsoft HoloLens 2. Some focus on art, some focus on design, some focus on prototyping. The list goes on. I don't want to spoil the fun, but there might just be one focusing on the Unreal Engine 2 if that's what you're interested in. For now, I know this is a lot of information, so don't worry about soaking it all in just this moment. We do have a newsletter going out on this topic later on this week, I believe on Thursday, and we're also going to be hosting an information session later on this month. Now, one of the things that differentiates our training and education programs is the one-to-one support that's included every week. In both our 10 and 8-week courses, every student gets dedicated appointments each week to work on their personal project. So the idea here is we're not only going to teach you everything that we think you ought to know as an XR developer, but we're also going to help you bring any ideas that you've got for a VR and an AR experience to life. Now, moving on, the second thing that we focus on here at CircuitStream, we are a professional content creation agency. Effectively, this means that we can help you and your organization by building training content in VR or AR that you would like to take back to work. We'll consult with you to better understand your employee training as it exists today and to identify any barriers to success that you might have. Finally, we'll work with your internal stakeholders to create an immersive experience that will meet and exceed your key performance goals and indicators. Alongside training, education, and content creation, the CircuitStream platform is a cloud-based portal that we launched last year. It's designed to help organizations host and scale their XR content. If you're not familiar with what XR stands for, it just means extended reality. It's basically an umbrella term that encompasses virtual, augmented, and mixed realities. In addition to hosting and scaling XR training content, it also allows organizations to easily track, measure, and analyze learning activities. Okay, so now that you've learned a little bit about us, let's cover why we're all here this afternoon. What are we going to learn? Well, today we're going to be covering an introduction to the Mars package and its intended use. We're going to discuss how to navigate the user interface. We're also going to talk about how to start, manage, and test your augmented reality projects within Mars. And we will definitely talk about some best practices and building habits. Now, I've mentioned Unity a few times already tonight. So for the beginners in the room who are unfamiliar with this program, I do want to talk about it just a little bit before passing things off to Jerry. Before I proceed with that, though, I am going to toss in a quick poll here to learn about your Unity experience. So give me just a second to do that. The question is, on a scale of 0 to 10, how experienced with Unity are you? 0 being you're brand new, you've never seen it before, and 10, frankly, you should be up here on stage with Jerry and I teaching this program. Give me just a second here. I am going to drop in the poll. Okay, it should be there for you now. So take a minute to go over there and to navigate to that poll. It really helps us out. For the folks who said 0, what is Unity? Well, Unity is a free 3D development engine for building games, simulations, and experiences. It is the easiest way to begin making XR apps. So now, how does one actually go about creating their own application within Unity? Well, just like anything, it all starts with a good idea. That idea is then designed and developed in an engine just like Unity. Once you've created and completed the build process, you push your application through what's called an SDK or software developer kit, and then ultimately your experience is hosted on the relevant device that you've built it for. I'm going to toss in another poll here just because I am really curious to know. Give me just a second here. But what device do you own? I am curious, so have a look there. Let's see what we've got. I'm always curious with this one to see what people have. Oh, the Quest is the early leader. It looks like a lot of people have the Quest 1 and the Quest 2. Few HoloLens owners here, a couple Magic Leap. Nice to see that throwback survive. That's awesome. Well, that's, today we're going to be focusing more on the AR projects, but we can definitely help you out if you're interested in the VR space as well. So moving on, what is Unity Mars? Well, the Mars package here is something that Jerry, who is much smarter than I am, is going to be teaching you about today. But before we do, I am going to toss in just a 2-minute sort of intro video for some of the newer folks in the audience here. Give me just half a second. I'm going to share that.
What's Unity Mars? Well, certainly not the planet, but it really knows this world. Unity Mars gives you everything you need to create powerful mixed and augmented reality experiences that interact intelligently with the real world at any location and with any type of data. Need to visualize a place or product, create a unique experience for an event, train up your staff? No problem. Imagine the possibilities as you author for games, sales, marketing, and more for any device or hardware platform. With Unity Mars, you can quickly capture and assemble real-world assets like locations, objects, and props. Then, just drag and drop them and test on the fly, all without leaving the Unity editor. Unity Mars experiences are powerful, interactive, and intelligent. Build once and deploy on any AR-enabled device. Get Unity Mars now and shape the world.
Okay, quick AV check. Can everybody hear me and see the presentation okay? Just a yes or no in the chat would be perfect. Awesome. Yeah, no, I love that video. It gets me every time. They did such a good job with Mars. And with that said, let's move on here. Today is an intro to exactly that, Unity Mars. So without further ado, I'd like to invite Jerry up on stage here. I'm going to pass things off. As I said before, he's a man of certifications, folks. He's our head of education. He brings a wealth of knowledge in XR development, and I'm thrilled to welcome him here today. So here he is. He just joined there. The man, the myth, the legend. Anyway, Jerry.
All right. Thanks, Kyle. Hello, everyone. Please, before we just start, let me know if you can see me and hear me well. Just quick AV check. How is it on your end? Everything is fine? Yes, yes. Great, great. Cool. Good. Wonderful. So I really loved that video, and I think that introduced quite well what Unity Mars is. But before we join the Unity editor and I show you guys what Mars is capable of, I would like to just quickly share a couple of slides here to give you a better overview of why I think Mars is a wonderful tool. Just give me 1 second. There we go. You should be able to see my slides right there. Yeah, it's not on the correct one. Cool. So as we said in there, Mars is basically something that allows us to create AR experiences inside of the Unity editor, right? But before Mars existed, we already were creating AR in there. So I would like to start with why I think that Mars is a good tool for us, especially if you were starting developing AR right now. The first challenge, in my opinion, that exists when we are making AR applications is that it's super hard to test on site. So in that video, for example, they're like an event where you have the fireworks and it's in a specific place in the world. So without Mars or with the default tools that we have, we need to just go to that place. So if I'm making something for a museum and this museum is in New York, I just need to go there to test it properly. So this is like the first thing that I think is super hard about developing and test AR. The second thing is that the world is super complex. There are so many variables out there, and it's super hard to define every single variable. So if I'm making like an application, an AR application that overlays something on the top of a table, there are so many tables in the world. Like they have different sizes, different heights, different colors, different shapes. And if we need to define every single variable manually, well, we're going to be spending our entire life just defining these things. And this is something that we usually need to define when we're writing an AR application. And the third one is that even though we define all of those variables and we are able to go on site and test the AR application, it's not simple to make it feel like the virtual content is actually interacting with the world constantly with the real world in a natural way. So we need to make them merge together somehow. Like we have to implement a couple of strategies to make it feel like the content is it's placed in the world. And sometimes we have like multiple virtual objects and multiple real objects, and Mars helps us a little bit with that as well. So what Mars is, just like a wrap up, is basically a set of tools. So it's a couple of tools that exist inside of the Unity editor, and it allows us to create, test, and deliver intelligent AR experiences. And when we say it's intelligent, basically what I'm telling is that we don't need to define every single thing. So we just need to create a couple of rules, and Mars is able to understand the words and match the word against those rules. And it helps with those three main challenges that I mentioned. So the first one that is, I think they are out of order, but the first one is that it helps us to, instead of define every single variable, we can just create content in a very comfortable and interesting way. It offers like a visual workflow where you just need to drag and drop stuff. We almost don't need any code. And it defines all the variables of the word in a fuzzy way. Like you don't need to determine every single thing in a very specific way. So you can determine like that, I want to place this on a table and I don't need to give all details about a table. It's going to be able to find what it is. It also helps us with how the objects interact between themselves, among themselves, and with the world. So we can define forces, determine areas where they can they can be placed. So we have like a couple of things to define how we want the content to interact. And in my opinion, the most powerful one, the one that I like the most, is that we can actually test it without leaving the editor. So I can test in virtual kitchens, virtual museums. I can test on a virtual bedroom, and then we can just check how our application is behaving in different conditions, and then we can just adjust that without needing to go on site and test that once again. So those are the things that I like the most about Mars. I think that they help us with those challenges. And the last thing before we open Unity here is actually how Mars is structured. So Mars is structured on top of the Unity XR stack. And this is very good because it just means that we can write our application once using Mars, and Mars is going to use AR Foundation to communicate to all XR subsystems that exist in Unity. So we can like detect the planes, it can place objects in there, we can make face recognition and those things. And the Unity plugin framework can just communicate with native providers. So we can build our application to Android devices, iOS devices, HoloLens, Magic Leap, or wherever existing there that supports AR. And we just need to care about our application in Mars. So this is something very, very interesting and powerful about Mars as well. Cool. So I think this is what I would like to share regarding the concept of Mars and why it's important and what it helps us with. Now I can just go into the Unity and show you guys what it's possible to do. Let me share my entire screen here. There we go. So here I have Unity. If you have never seen Unity before, so this is how it looks like. I already have Unity Mars installed in here. You guys are going to receive after the webinar a document that teaches you how to subscribe and download Mars. It's not a free tool, but they do offer a free trial, 45 days that you can test it. So that's why I cannot just show you guys right away how to get it, because you need to subscribe, but you're going to receive instructions on that. So this is my Unity editor. I have a couple of windows in here. If you're not familiar with them, let me just explain the most important ones. So here on the left, I have the hierarchy. This is where I see every single object that exists in my scene. So every time you create a scene, you're going to have like the main camera and a light. So those are like the most basic objects ever, but we can create more, and we're going to be creating more. Then we have here the scene. The scene view is basically where we edit our object. So if I want to move the camera, for example, I can just see where it is in the world. I can also do the same thing for my lamp, for my light in here. So this is the scene view. It's like basically our level editor. More to the right here, I have the inspector. This is basically where we can check the properties of every single object that exists. And we can also change those properties. So if I select my light here, I can see that this is a little bit rotated. I can change that. There's the color of the light and more properties. The same for the camera. So we change properties here on the editor. On the bottom here, I have the project tab. This is where I have every single asset in my project. So if I import 3D models, textures, sound files, scripts, anything, they're going to be here. Here's where we organize our project. If you're not seeing them in this order, it's not a problem. Actually, we can customize it. We can change the order of the tabs. We can create our own layout. We can also go here to Window, Layouts, and then select one of the predefined ones or save ours. So I'll just change to the default layout. If you have just installed Unity, it should look something like this. Cool, but now let's start seeing what Mars adds to Unity. So this is the basic Unity project. If you don't have Mars, this is what you're gonna see. But if you do have Mars installed, when you click on Window, you're gonna have this new option here, which says Mars. And then we have a couple of options in here. And we're gonna be seeing what they actually do, especially the Mars panel, which is like the hub for accessing all of the things that Mars offers. Before we click on this and see what menus this thing offers, let's set up our scene for working with Mars. So there are a couple of things that we need to do here. The first one is getting rid of the main camera, because this camera is like a virtual camera. This is not aware of the real world, but every time that we are working with AR, we need to have a special camera that's able to track the real world. So I'm gonna delete this, and I will create the Mars camera. So the easiest way of doing that is just right-clicking here in the hierarchy. We have a menu which is called Mars, and here we have everything that we can create. And I will just create this object, which is the Mars session. So the Mars session is basically the object responsible for the Mars life cycle. So this is gonna initialize Mars and start tracking my camera, getting data from the world, and then bringing that into the Unity editor. As a child of the Mars, we're gonna have the camera. So every time that my world moves around or my device moves around, this camera is gonna move as well. That's why we're not using the default camera that came with the scene. This camera has a special component in here, which is the Mars camera. We don't need to change anything here. Just be aware that you need to create this instead of the base camera from Unity. Here, if I select the Mars session, I have a couple of options here that we can change. We don't often change those things, but there is an important thing here, which is basically the world scale. So most of the times you use like the default, which is 1, but if you are making like micro simulations or macro simulations with things that are super big, you can actually change the scale of your word in here. But for now, or most of the times, you just use 1, which is like the default word with no scale. Cool. So now my scene is ready to work with Mars. We already have the Mars session in here. We can start now to understand how to work with the Mars pipeline. So one of the most important concepts of Mars is what they call a proxy. So a proxy is basically a set of rules that match something in the real world. So we can start identifying that. So say, for example, that I want to find the floor or flat surfaces on the real world. The first thing that we can do is create a proxy here. It's quite easy as well. We just need to right-click and then Mars. There are 2 ways of creating a proxy. We can just create one from scratch, like it's a proxy which is completely empty, and then we can give the rules to this proxy, or we can use a preset. So the preset is always easier. Most of the times we can just use one of the presets, but if they're not complex enough, you can create them from scratch. So let's start with a preset. There are a couple of useful ones here, which is, for example, the horizontal plane and the vertical plane. So horizontal plane is gonna find things like the ceiling and the floor. So let's start with the horizontal plane. Then, now that I created this proxy, this is a horizontal plane. We can still not see anything here just because we didn't add anything to our scene. But if I select the horizontal plane, what I can see here is that it does have a proxy and a set of conditions. So the conditions are basically the rules for this to be detected in the real world. For the plane, we have 2 conditions here. The first one is plane. So every time that Mars intelligently finds something that is a plane in the world, this condition is going to pass. But as we are using a horizontal plane, there is another condition here, which is the alignment condition. So basically, I'm not detecting every single plane out there, just the ones that are horizontal up. So horizontal up is basically like floors or the top of the tables. The normal of the plane is facing up. And if I change it to horizontal down, for example, this is gonna be now the ceilings or planes where the normal is facing down. So basically, this is like the most simple plane condition that we can add. So let's make it being horizontal up, like the floor. And then how the proxy works. So say, for example, that I want to place, as soon as I find in my real world an horizontal plane, I want to place something in there. Like, let's start with something very simple, primitive. I'll just create a cube here. I want this cube to be a child of the proxy, and I will make that on the 0, 0 position. So here it is. Now, every time that Mars finds the first plane in there and this plane in horizontal, it's just going to make this cube pop up on top of that plane. One interesting thing that we need to notice here when we are dealing with AR is that the size and the scale matters a lot because we're dealing with the real world. By default, I created this cube in Unity. Every time we create a primitive in Unity, this is 1 by 1 by 1, and this is in meters. So this would be like a 1 meter by 1 meter by 1 meter cube in my word. Let's make that a little bit smaller. So now this is 20 centimeters by 20 centimeters by 20 centimeters. Cool. So now, as I mentioned in the beginning, one of the challenges of building AR is that now that I want to test it, originally I would need to build this on my Android device or HoloLens or wherever, and just walk around my house to see if this is going to be placed on the plane. One good thing about Mars is that it provides a couple of tools for us to test it. So if I click here on Window and then Mars, I have 2 things here that allows me to test. The first one is the simulation view. So if I click on the simulation view, there is this environment in here. And look at that. My plane is already placed on one of the vertical plane or one of the horizontal planes. The first one that Mars identified. We can test on different environments. So they do have here a couple of templates where we can test. And we can see how it would behave in a kitchen, for example. It can determine how it would behave in an office, for example. So the first one, the first proxy that was determined, that was found, is basically this plane, and then it's placed in there. So usually, when you just use a simple proxy, Mars just places that in the first one that it finds. If we want it to be placed in multiple planes, so say, for example, I want multiple cubes in my scene, we need to use a different component, which is called a proxy replicator. So I can just right-click here, Mars, and then proxy replicator. I can drag my proxy as a child of the proxy replicator. And then I can determine here how many of those I want to place in my scene. 0 means, well, as many as you can find. So 0 is like infinite. But say, for example, I only want 5. Then if I go back to Window, Mars, and then Simulation View, look at that. Now I have 5. 1, 2, 3, 4, and probably 5 somewhere here on the floor. So it just detected more planes because I have the replicator. And this is awesome because I can just test it and test it very easily. And that's it. Another thing about the conditions is that they can be a little bit more complex. So let's see how to make it a little bit more complex. So I'll just delete everything that I did in here. And now I do have here in my project a clock module that I already have. So this is like just a simple clock module. Say, for example, I want to place this in my wall. So let's start creating a proxy for the wall. I will just right click here, Mars, and then where is it? Presets, vertical this time. So I want vertical planes. And then we can see here that the only difference when I click on conditions is that now my alignment condition is basically vertical. And I want this clock to be a child of the vertical plane. So it's going to be placed on vertical walls. It seems like I can change the, no, that's actually correct. My clock is not aligned with the plane, so for some reason I will just rotate this clock here like 90 degrees to make it aligned with my plane. And now let's go back to the simulation view and see how it goes. So when I click here, Mars, and then simulation view, I should be able to see this on my environment, right? So we can see that this is placed on the couch in there. This is not exactly what I want, so I would like to have this on the walls, not on the couch. What we can do here is start to understand what is Mars finding out here, why Mars is placing this on this plane. So if I click on the vertical plane here, which is my proxy, I do have this compare in simulation view button. This is gonna tell me where the planes are. So if I just hover here, you can see here that it's gonna tell me that this is a plane and this plane is aligned. So this is a vertical plane. And that's why it's able to place it here and here and here as well. And here is not placing because this is horizontal up. So we can start, when we use the compare view here, we can just start to understand how Mars is perceiving our world, and then we can adjust our rules and iterate over it. So let's make this a little bit better. I don't want it to be placed on the couch, just on the walls. So what I can do is maybe make a rule so it doesn't go on smaller planes. So let's see how we can do that. I can just click here on my vertical plane, add another condition. There are a couple of conditions here. One of the easiest one is the plane size. So if I click here on plane size, now I can edit the minimum size and the maximum size of this plane. So say, for example, I only want it to be on a plane that is at least 2 meters by 2 meters. If I hit play here again, I can just see if this is going to detect any plane. And now it didn't detect any plane. There is no plane here that matches my condition. So let's try to optimize it even better. It is still comparing, so let's wait a little bit. Why not? Well, it should be just comparing. For some reason, it's taking longer than I was expecting it to. Oh. Yeah, I don't know exactly why. Let me try again. Let me try again. Compare simulation. Yeah, for some reason, it's stuck. Yeah, for some reason it's stuck. Not sure what happened here. Let me save the scene. Maybe I will need to restart Unity. Anyways, we can extend on that further. So let me try to change it to a smaller one. Maybe you can see something different. Let me see. Window, and then simulation view. There we go. It was just thinking. So now that I'm using a different plane size, we can see that my clock is placed on a better plane, right? It's not placed on the smaller ones anymore, because this one is basically in this range. So it's at least 1 meter by 1 meter. And this is one more complex condition that we can add here and we can compare. So this is very useful. We can iterate. So we just fixed it. Now it's not going to be placed on the smaller planes anymore, and we can add more and more conditions until we have it matching our proxy for the real world. There are a couple more conditions. I'm not going to show every single one, but one interesting one that I like is the geofence, for example. So the geofence is basically like, I want this to be placed on a plane, but only on a specific place on the world. So we can just use the coordinates. So if you want to be like a specific square or museum or school, I don't know, you can just add it here, like the extents for the latitude and longitude, or you can select a city from here. They have a couple of cities to help. It's just like presets, but you can just find out the extents for that specific place you're looking for and add this condition. Cool. And another view that we have, we do have this simulation view that just shows the entire simulation, but that's not how things really work. When we deploy to the device, we need to move the device around, and it's going to recognize pieces of the word and save that. So if you want to simulate that behavior as well, we can use something different from the simulation view. We can use another test tool here, which is called the device view. So the device view is going to basically behave similarly to our device. So when I hit play here, I can just use WASD to move around. And this is my this is how I would scan the world in real life. So I can see if the planes are being detected or not. And as we can see, now my clock is here. So it took a while for it to recognize that my clock should be placed on here. I just realized it's facing the other side. We can fix that just rotating this. But I wasn't able to see what Mars is seeing here. So another thing that we can do is actually add a couple of visualizers. So they're just debug tools, but they're going to show me exactly what Mars is seeing. So let's add a couple of them. The first one I'm going to add in here is the they are under data visualizers, so they are basically just to help us debug it. I will create a plane visualizer, and I will also create a point cloud visualizer. So now if I go back to that view, which is the device view, and hit play, we can see that, I'm not sure if you guys are going to be able to see, but there are small points in here. Those are the points that Mars is seeing in the world. The green ones are high confidence one. The red one are still low confidence. Like, they are not super sure this point is important. But if I start moving around, now we can see the planes in here. So this is how the device works in the real life. And we can simulate that behavior as well. Just moving around and scanning the environment until we can find a plane that is under the conditions that I created. And then it's going to just place my plane on that, my clock on that plane based on the condition. So this gives us a better view of the experience of the final user, because this is basically how the device is going to be recognizing the world and placing the objects in there. Cool. One thing that is interesting about Mars as well is that we have those default places in here that we can test, but you can actually bring anything in here. So we can just create your own environment if you have like CAD data, or if you have modeled a specific place. You can just bring that inside of Mars and start testing that on your own here. So you have like a real understanding of what's going to happen on your application, and you can adjust, iterate, and then build. Cool. So in general, this is what Mars does. Like, it has a couple of options. You can create those presets. You can also create other proxies. You can add content dynamically here and add conditions to those objects. You can create like a set of different conditions to match something in your real world, and you can actually iterate real quick. The last thing that I'm going to show you guys here about Unity Mars and how it works is another thing that is quite challenging when we are making an application in AR is most of the times we have trouble building that because we don't have all of the libraries, everything that we need. So Mars helps us with that as well. If we just go here to Window, Mars, we have this build settings check, and I really love this. When we click it, it's going to tell us that something is missing. For example, I am not on an Android or iOS or Windows or Lumen platform. So basically, my project is not set up for anything that supports AR because I'm on my PC. So this is like the first thing that I need to check. Go to Android and then click on Switch Platform. And then it's going to give me a list of things that I need to change in order to build this for Android. Or if I change that to, well, iOS, for example, this is going to give me a list of things that I need to do to build for iOS, similarly to HoloLens or any other platform in there. So it's super, super useful. As soon as we define where we're going to build for, it's just going to tell us every single thing that we need to import in that. So cool. I think that's what I would like to share with you guys. So Mars is basically this, like a set of tools that helps us to model our real world and then create content in here and test this content without going out of the Unity editor. I will invite Kyle back to the stage just to wrap this up, and I will go back in a couple of minutes to answer all of your questions if they exist.
Awesome. Okay, folks, you know the drill by now. I've done this a couple of times. AV check, thumbs up in the chat. Please do let me know. I'm going to share my screen here as well. If someone in the chat, awesome. Thank you, Dario, much appreciated. Give me just a second here. I'm going to pull my screen back up. Awesome. Okay, well, thanks again, Jerry. I always love seeing what you cook up for these workshops. You never fail to impress. I can see that we've had some questions asked throughout the presentation, and I want to make sure that we do have time to address them all here. We've got about 20-25 minutes remaining available here. I'm going to take a few more minutes here just to wrap things up before re-inviting Jerry back on the stage to help us with the Q&A sessions. This is a reminder too. I know that we flew through the content this afternoon. It was pretty quick. We will be sending out the recording of this workshop to everybody who signed up, even if you had to take off earlier or weren't able to make it. You're also going to have access to a couple of the project resources, the video that I shared and that type of thing. Before I do proceed though, I am going to drop another poll here into the polls tab. So if you can navigate over there, please do take a moment to answer this one, as it really helps us improve and create more workshops just like this today. So on a scale of 0 to 10, how likely are you to recommend this workshop? Please have a look there. This one's really important for us. Okay, moving on. I really like this slide. If you enjoyed learning with us today about developing AR apps with Mars or any of our other workshops and webinars that we share, we would love to have you or your team join one of our educational programs. No matter who you are or what your current skill set is, we can definitely help. Whether you're a team or an individual looking to change careers, whether you're looking to start your own business, bring this technology back to your work, or train together as a team, we would be more than happy to connect with you to see if your goals align with what we have to offer. And as a reminder here, I did promise that I would speak about this one earlier in today's presentation. The XR Development with Unity course really is the flagship program here at CircuitStream. It's designed to teach you how to build your own VR or AR experiences from scratch using the Unity engine. It's taught live and online just like today, and it includes 40 hours of education taught over a time span of 10 weeks. It includes 10 hours worth of one-to-one appointments with instructors just like Jerry that you're welcome to use however you'd like. But you should know that we would love to help you bring your very own project idea to life. Our course tuition fee is $3,950, and the next cohort gets started on the 1st of December. Again, we're going to be talking about how to make our own apps, covering the fundamentals of C#. There's 4 hours of class per week for 10 weeks, and you get weekly one-to-one support. There is no experience required, so beginners definitely have no fear. Moving on, if you're listening to me talk about our beginner-friendly 10-week course, and you're thinking to yourself, hey Kyle, I'm already proficient in Unity and in C#, but I'm so absolutely blown away by Jerry's teaching skills, and I absolutely have to continue my learning with CircuitStream. Well, first of all, we're very flattered. That's very kind. You shouldn't have. But second of all, and more importantly, we should definitely chat after the webinar. We do have another program that might be a good fit. I've referenced it earlier, but you can see it there on the right. It's called the XR Project Accelerator course. It's an 8-week intensive course that has labs to help you continue your applied learning. But the real star of the show here, in my opinion, is the amount of one-to-one support offered in the program. Each student here gets 3 hours every week to meet with their instructor, where we can focus on you and your projects to help you bring them to the next level. The course tuition fee for this program here is $4,450 US, and the next cohort gets started on January 5th. For both the 10 and the 8-week programs, we do offer payment plans of 3, 6, and 12 months as well. Totally up to you if you want to take advantage of these. So if you do, just let somebody on the admissions team know, and we'll help you out. One of the things that I haven't spoken about very much today is our team training offerings. We do have a catalog that is available for download on our website. Basically, if your organization is making a commitment to building VR or AR apps in the near future and would like to send a group of team members into our programs to upskill collectively, we can definitely help. I've already mentioned that a catalog is available for download via our website, and we can offer these programs to teams in private sessions. The interesting thing to note about our team training offerings is that we can be really flexible on the content taught. We can make something custom to meet your learning needs. Additionally, unlike with the 10 and 8 weeks course where they're regularly scheduled, we can start these sessions pretty much at any time, and we can offer them in the Unreal Engine as well. If you are interested in any of what I've just spoken about, any of the educational programs offered here by CircuitStream, I'd highly recommend that you head over to our website and check out the learning page there to read more about what we offer. Additionally, you're more than welcome to reach out to myself or to any of my colleagues who are here supporting me behind the scenes this afternoon. On the screen there, you can see our email addresses. I think we've all tossed in our LinkedIn profiles as well. So if that's where you prefer to chat, please don't hesitate to reach out there as well. With all of that being said, I'm going to re-invite Jerry back on stage here. Let's cover some of those questions that were posted during his presentation. While we're speaking too, if anything that we're saying sparks any interest, please feel free to post your questions in the questions tab and we will get right to them. So I can see Jerry there. I'm just going to remove the screen share. So yeah, away we go. Is there anything that catches your eye, Jerry?
Yeah, so actually I am sorting it by upvotes in here. Let me start answering. So there is this one, how does Unity Mars compare to coding AR with Apple's AR Kit? So actually, Mars runs on top of AR Foundation, and Foundation runs on top of other providers such as AR Kit and AR Core. So everything that you can do with AR Kit, you can also do with Mars. The difference is that you don't need to code tons of things when you are in Mars, because most of the pipeline is actually visual. So you can define as many rules as you want, and this is going to interact with the world in a very, very seamless way. So actually, it's just like a wrapper that make our life easier. What I showed today, for example, detecting if the plane is vertical or horizontal, if the size of the plane. So all of those things, you need to actually code them, hard code them every time that you are working on only with AR Foundation or the AR Kit. So basically, it just cuts the production time by a lot because you don't need to code those rules or implement all of those rules. And it has like a couple of it uses artificial intelligence actually, so we can just determine a couple of semantic tags to detect what's going on in the world, and that's quite complex to write. So yeah, it's basically like everything that you can do with ARKit, you can do with Mars, but with Mars it's a lot easier.
It's a great question. There's a couple very similar to that one, Jerry.
Yeah. So there is one here which is good. I think I answered that during the workshop, but I think it's interesting as well. Can you import a model of a room if you want to place vertical objects in specific places? Yes, finally. So Unity Mars comes with those that I showed you, like the office, the museum, the background, the backyard, but you can actually create whatever you want. So you can just bring your models in there and assembly your own scene, and it's gonna work as well. There is a prefab that you just need to replace. You just need to place the components that you want inside of that prefab. But yeah, you definitely can do that. I think that's the whole purpose of Mars. So most of the times, if you're not working with something super specific and complex, you can just test with that ones that they already offer, but you can definitely bring your own modules to make it even more more specific and more tailored to your application.
Awesome. That's a great question. I think you've already covered this one here from Leon. I'll pull it up. The main differences between AR Foundation and Mars. Specifically the functionality here. Is there anything that you might add?
Yeah. So I think that in terms of functionality, there's no differences because AR Foundation is implementing basically a wrapper for the native implementations such as AR Core and AR Kit. So everything that you can do with AR Foundation, you can also do with Mars. Mars uses AR Foundation on its basis. So I think that the usage is the big differences. As I said, Mars defines a visual workflow that is super smart and easy to use. So basically, it just cuts development and iteration time. And you can actually focus on the experience that you want to deliver instead of focusing on like every single technical detail in implementation, every single condition and variable. So it's feasible to do everything that you do on Mars with AR Foundation only, but that's a lot of work.
Awesome. What else catches your eye here, Jerry?
There is one in here which is good, which is Yeah, it's very similar to the one that I just answered, but there is one thing in here, which is if it works with image targets. And I think there's another question which is similar in there. Yeah, it does. So everything that you do in Mars, you can do in AR Foundation, and everything that you do in AR Foundation, you can do in Mars as well. So yes, Mars does work with image targets. Someone asked if it should be in the presets. I think it was Lawrence in here. And oops, how do I stop this? I'm done this. Just this one here, which is very similar. If it should be in the presets. Yes, it is in the presets. So if you right click on the presets in there, you're going to see that one of them is image target. So if you create that preset, you can just upload the image. It's going to recognize that image as well. So image target is one of the presets. So image target's like the simplest way of providing AR experiences, because it's just basically finding an image somewhere. It's not really integrated with the world. That's why I focus on planes, because I think it's a little bit more impressive, more difficult to code. But if you just need to use image targets, you can use Mars. You can simulate with the image target without building as well, because you can place a virtual image target on the scene, on one of those scenes that I showed, and then just debug your application as well. So yes, you can finally use image recognition in there.
Awesome. I saw one from Carissa. I think you did address this one. So Mars integrating with the mixed reality toolkit. Is that different from MRTK with the HoloLens?
No, yeah, actually it is MRTK. MRTK is the same one for the HoloLens, and no,
okay.
Mars is not going to work with that. So the MRTK is in a different stack. Actually, you can use Mars and publish to the HoloLens, but through AR Foundation and the Unity stack using the Universal Windows platform, but not with Mixed Reality Toolkit. Not sure if someone out there is working on a workaround. I've seen that so many times, like, well, people that just hacks the system and makes it work somehow, but there's no official support for that.
Awesome. Okay, I will get that out of here. I saw one in the chat, actually, that I thought was interesting. Unfortunately, I can't start a live channel, but from Diego, can I combine 3D body tracking and plane tracking or meshing with Mars? That's a complex one.
Where is
it's
it?
in the chat. It's in the chat.
Oh, it's in the chat. Let me see here.
Yeah.
Can I combine 3D body tracking and plane tracking or meshing? Yes, you can. You can. They finally can. So AR Foundation does support body tracking and plane tracking. One thing. Yes, and you can use that with Mars as well, because Mars is on top of AR Foundation. Maybe that's not like super straightforward, but that's possible. One thing though is that body tracking only works on iOS because it's supported by ARKit, not ARCore. So if we're planning to use body tracking on Android, I don't think that's a possibility unless they updated something, and I'm not, only for iOS. Maybe they implemented that in the meantime, but the last time I checked, body tracking was not supported by ARCore yet. So yes, you can definitely do that. That's a good challenge. I have never tried that, like body tracking with Mars, but that's definitely possible somehow. iPad Pro with LiDAR sensor. Yeah, that might work for meshing. Yeah, that's a good experiment. But yes, definitely. So just bear in mind that Mars is written on top of AR Foundation and AR Foundation on top of ARKit in your case for iOS. So yes, you can do that somehow. Just need to find out. Probably you're going to be the first person in the world to do this if you just do that in the next couple of weeks, because Mars is quite new. So there are not lots of applications yet out there. So if you do that, just share with us, because you're going to be the first one ever. Probably.
That's exciting. There's a recently upvoted one here from Leon. So I'm going to start a live answer here. LiDAR sensor support. We just talked about the iPad. It's kind of relevant. So
yeah, how about LiDAR sensor support for the new iPad 2020? Is there further development for that? Yeah, definitely. So the new AR kit already supports the LiDAR for occlusion, body detection, and meshing, and all of those things. And if there is already a preview package of AR Foundation that works on top of that. So I have not tested that myself, especially because I don't have an iPad 2020. but yeah, it's still like in preview and people are working on that. But it's gonna come out like a stable version very soon, because I know that there are lots of people working on that. But I think that's already supported. I'm not really sure if the support is super good, but it does exist. You can use like area targets with AR Core, not with AR Core, with AR Kit. So that might be backported to AR Foundation soon as well.
Nice.
Cool.
I saw one on AI from Jason. I thought that one was interesting. This is
it on a
definitely
chat?
your area of expertise. Yeah.
Have you seen any AI waypoint finding technology with Unity Mars? Well, I know I haven't seen it, but that might be super easy to implement, being really honest with you, because pathfinding is the most in artificial intelligence. Like this is the first thing that you always learn. So there are so many good algorithms like the A*, and that's super easy to implement. And when you have like those planes, you can use like navigation meshes on top of that. So I didn't see anyone using that up to this point, but that's super easy to implement with Unity, because Unity already have the nav mesh implementation, and you can just implement other techniques if you prefer, like waypoint navigations without the nav mesh, just with the regular waypoint. So it's just basically like a matter of implementing that, but that might be super easy to do.
Nice. This one's really, really simple. Jerry, do you know the cost of the Unity Mars license? I know it's a monthly fee. I just off the top of my head, I can't remember it.
Yeah, so it's $50 a month. I know that they have like 6 months and probably a discount on that, but I'm not really sure. If you decide to pay monthly, it's $50 US dollars. Awesome. But you have like 45 free days, so you can test it and experiment and determine whether this is for you or not.
Right. Yeah. Really quick one there. Anything else catch your eye? Just scrolling through, upvotes not answered. There's a few in there.
There is one good question here, which is there any plan on Cloud AR, real world anchor that could be used in AR? That's already possible with AR Foundation. I haven't tested that on AR Kit with iOS, but I have tested that with AR Core and Android. They do have cloud anchors already. So this is something that you already can use. You just need to use the Google APIs and set that up. But yeah, that's already supported on AR Foundation. This is something that you can definitely do.
Nice. Okay.
I always minimize this stuff of saying I'm done. Let me see if I can see more here. Oh, this is a really good one. So, of course, to design the experience for Unity Mars, we need a license. What about the end users? Do they need a license too, or simply export the experience and they can use it? Yeah, so they don't need to have a license whatsoever. It's just like you as a developer, you do need to have an active license, and then you can deploy and publish your applications, and that's it. So the end user doesn't need to pay anything for that, just you as a developer.
Nice. That's good to know.
Yeah.
I thought I saw one here. Here's one that relates to coding from Artur. Can we create a proxy object in, I don't know what fly is, from C# scripts? And also, can we move that object that will be placed in proxy instance after placing it in a real world? That's a complex one.
That's a really good, that's actually a really good question. So yes, you can create a proxy object on the fly using C#. So you can just determine the parameters of that proxy and place that. That's something that we can do. You can also extend the ones that already exist. You can create like different semantic rules, and that's possible. That's something that usually we do that, right? I was just demonstrating like the easiest way of making a simple application, but you can go that complex as well. And if we can move the objects that was placed, we can definitely move it in different ways. So there is one way you can move it without coding, which is using something in Mars that's called the force. So we can just say, for example, well, if something happens, move and adjust, but you can also code that as well and move it the way you want it to move. So yes for the both questions in there.
Nice. I saw another one here, and it's from Mark. It's discussing multiplayer and limitations. I can address the second part of this question, Mark. We don't know. We're partners with Unity. We're not on their team. So unfortunately, not sure about planned releases for the future. But multiplayer, that's an interesting question. What are your thoughts, Jerry?
Can you share a presentation with multiple users on different hardware at the same time? Yeah, finally. So yeah, as Kyle mentioned, with multiplayer, you can finally connect people over the internet and wherever you want to do in there, and show that there are a couple of ways to address this. This is not super simple. Like it's not impossible, but there is a couple of things you need to do in there. It's a little bit of work, but yeah, that's finally possible. And about the limitations and releases, as Kyle mentioned, there is only one thing I've heard from Unity, which they're calling the rule system. So they're gonna make the this conditions workflow even easier. Like if this happens and that happens and this, so it's just basically like a set of rules that you can add to your proxy. They are working on something easier for that. I've seen a demonstration. I didn't have the chance to play with that, but this is the only thing that I know. I'm pretty sure they are working on more things there as well, but well, that's probably secret.
We will see. Jerry, I think we've got time for 2 more questions here. So if anything catches your eye, please feel free.
Let me see. If
I'll scroll through myself as well.
Oh, there is one which is good here. Can a point cloud module be loaded and using with Mars? Not really, not because of Mars, but because of Unity and other game engines. So usually we don't work with anything that is not a mesh. So modules in game engines are represented by triangles and mesh. So we don't use cloud points. So if you are able to convert that point cloud into a mesh, then yes, you can use that. You're probably gonna need to work on the retopology of that, so it's simpler, because cloud points are super heavy. But the simple answer is no. The complex answer is maybe, if you can convert that in something different. But the GPU doesn't work super well with things that are not triangles. So especially for runtime, like games and applications, you need to run on the fly, like everything needs to be runtime. We don't use cloud points for that, or point clouds actually.
Awesome. Okay, Barry, we got time for 1 more here, and then I've got one last thing that I want to share, but let's do a question first.
There is one. It's from Diego. There's another one here. I'm not sure I am able to answer this, but he's asking how much time takes to fully understand Mars. So it depends. It depends on your how familiar you already are with AR and Unity. So you just go straight into Mars. So for my example, like it took me like 1 week working with that, like 1 hour, 2 hours per day. But I've been working with Unity for 10 years and with AR for like 6. So I was just transmitting what I know to Mars. But I think like 1-2 weeks, if you are like intermediate to advanced, if you just dedicate a couple of hours every day, 1 to 2 weeks. It's not like super complex in terms of the user interface and what it offers. So it's just basically getting familiar with the things in there. But yeah, I think I would say like 20 hours, 25 hours, you can get 100% of what it covers right now. Of course, they're going to be releasing more and more features, but to the point it is right now. That's just like a guess. I'm not really sure. It depends on you.
Awesome. Okay, Jerry. Well, as always, really appreciate you sticking around for these Q&A sessions here. Your experience is super invaluable. For the folks that are left, if you scroll up a little bit in the chat, my colleague Jason behind the scenes, he did share a couple of links for you all to check out. I think we're going to do a pop-up here on the screen in just a minute as well. If not, they are links. I mentioned the 10-week course, so there's a link to the course page on our site. The 8-week course, there's also a link there. And then most importantly, for now, I think it's on the 18th, we are hosting an open house where we are going to talk about all of the programs that we offer in depth. So if you're thinking about these programs, you want to learn more, you want to see if they're for you, there's the pop-up there. Feel free to go sign up. It's a totally free workshop, very live, sort of like we're doing today, very discussing all of our programs. Feel free to check that out, as well as any of our other programs. As always, please don't hesitate to get in touch with anybody on the education team as well, as we'd be happy to meet with you one-to-one. But for today, that's all we've got. Thank you for sticking around to the end and for checking out our workshop. It's great to see everybody in attendance, and looking forward to see you at our next one. Bye-bye for now. Stay safe, everyone.
Bye, everyone.